What are foundational models and why should you care? Well, ChatGPT is a foundational model, so is Google's Bard or Anthropic's Claude. There are many of them, and there are more coming. So, what are they and what will they do? Well, they're going to do a lot. Sooner or later, they're going to subsume most of enterprise software, customer service, analytics, HR. They're coming. Find out more on this episode of Future Proof.
The future is here already. It's just not evenly distributed. Yet. Today's world teems with innovation. The nexus of hardware, software, and human ingenuity promises a revolution in possibilities. What does tomorrow look like? Witness Future Proof.
Yours truly, Eric Kavanaugh, here. Very special show today, folks. Very special topic. I wanted to get one of the smartest guys I know on the call, and we sure did. And we're going to talk about something that is absolutely freaking mind-blowing. You've seen it around. You've seen ChatGPT. Some folks have seen Dolly and some of these others. There's a whole bunch of them now. They're called foundational models. Of course, large language models are foundational models, and those are what are really blowing people's minds. And they are really good. I'm telling you, they're getting better. I was using Bard earlier today. It's getting really good because you remember the initial limitation on ChatGPT when they rolled it out through OpenAI was that it was only trained on data up till like September or something 2021, and so it didn't have current information. Well, Bard doesn't have that problem. I'm pretty sure that the OpenAI is dealing with that as well, incorporating search. Microsoft, of course, with Bing, still trying to catch up to Google. I mean, wow, Bing still has a teeny tiny bit of traffic, but I'm thinking that's going to be changing in the next year or two as people dive in and use this stuff. And Google, of course, is overloaded with sponsored links. You got to like scroll down, like, where are the non-sponsored links? Is there content? I even heard from a very well-connected individual in Silicon Valley that even the organic links on Google searches aren't organic anymore. That's what I heard. Heard that there's some people on the inside who were able to get some influence, and the organic isn't quite organic. But these are for-profit companies, right? This is not a public service that they're delivering. Maybe someday the government will deliver public service. We'll see. But the topic for today is foundational models and will they subsume or short circuit enterprise software? And with us to talk about that is Justin Reock of Cortex, cortex.io these days. Justin, welcome to the show. And what do you think, man? Like maybe just from your perspective, explain what a foundational model is and what you
Yeah,
think about this Cambrian explosion that's coming.
sure. So first of all, great to be back on the show. Been a little while. Really good to be talking with you again. I know we've done some stuff off air recently, but really great to be back on the air with you again on this wonderful show about data. So let's talk about data and how that defines sort of the difference between what you would consider more of a task-driven model and now these foundational models that we're training as AI. So the foundational model are basically here for large language models. I think that's probably the one that's really got us all interested right now. But also these stable diffusion models like DALI and image generation models are considered foundational models as well. Basically, the difference is that instead of trying to train an AI to perform a specific task really well by giving it very context-specific data and really indexing a lot on that data, a foundational model instead says, no, we want to be able to train this model on incredibly broad subjects. We want it to be able to develop a context and even a lateral way of being able to analyze these pieces of data so that we can use it to do more general things, like, for instance, answering questions or generating images out of nothing, right? So I think where the foundational models become so exciting, and especially for things like the way that we might change software design patterns, is that there is such a wide palette for how they can be used, right? I really would encourage everybody right now to go check out some of the options that you have for running these models locally, so that you can get a feel for the difference in what are the communities surrounding these models and what are they being used for, but even be part of discovering some of these use cases yourselves. You can LM Studio is probably the most well-known open source solution for this. So yeah, that's how I would define them, right? So instead of being able to train them on very specific tasks, we're able to train them much more generally. And why, why the word foundation is that because then we can use these models as a foundation to build other types of more general solutions, right?
Mhm.
That's the key right there. Because now think about how fixed and dynamic parts of our software still are, right? Think
Mhm.
about how many static bits of text you look at in an app, or think about how many, I should say, how few ways of providing input you have to an app, right? And think about how those are fixed in the ontology of the app itself. Input fields and text fields and rich context that's presented to you in a very static way.
Mhm.
What something like a foundational model opens up a possibility to do and unlock, and I'm not saying that we have proven this yet, but we've now unlocked the ability to create much more dynamicism and
Mhm.
context awareness inside parts of our applications that were previously static. In other words, replacing static text fields with dynamic output from an LLM. We see this in very small doses now. If anybody's had a chance to play with like the Copilot integration with VS Code, the current release of it, if you get a stack trace error, you now embedded in the IDE says explain, with Copilot. If you click it on the left
Right.
side of the IDE, a GPT window opens up and it's explaining what happened in the stack trace. Does it hallucinate a lot? Yes, of course it does. Right. But the point is, it is saving me from leaving my IDE to go and do what I'm probably going to do, copy and paste the error into Google and see if I can get a Stack Overflow explanation. Right. I don't have to do that anymore. My IDE now just explains it to me. But this is still just the most convenient way to shove it in, because we still just sort of have this one interface for the models. One thing you'll notice with LM Studio is that I love it and it's really cool, but it's this very fixed method of, okay, download any model you want from a marketplace, then click the little chat part of the tool, select what model you want to chat with, and start chatting. That's very, very cool, but that's all you can do with it right now, because you can chat, right? So as we start figuring out new methods of input that can be interpreted by these LLMs, then we complete that bidirectional dynamicism that I think really can shift our design patterns in ways that haven't been shifted before.
Yeah, and you mentioned one very simple thing, which is that now you can just do this right click or this function inside your IDE, your integrated development environment as a developer, and see inside that environment. Well, I think you were the one who introduced me to the swivel chair concept. It's like, okay, I saw this, now I got to swivel over here and see that. I got to swivel over here, bouncing between apps. Guess what? Nobody likes that. Nobody wants to be bouncing between apps. You want to be in one app and one screen, have what you need there. And to your point about dynamism, being able to incorporate new components, new chats, like have your Slack window come right in there, but to have that LLM in the background or that foundational model in the background, I mean, this to me is really quite compelling in terms of certainly software development and then of course software use. You're basically augmenting whatever application you had. And we could talk later about how it's going to transform journalism, how it's going to transform education. I mean, so many different things. You can sit down and have these conversations with your virtual assistant who has a tremendous vocabulary and the biggest encyclopedia imaginable. The only challenge right now, I think that I see is that they do hallucinate. They make stuff up. They have errors because, as my buddy once said, they don't have an epistemological boundary. In other words, they don't know what they don't know, and that's why they make stuff up. So, I think the stronger the RAG model gets, the retrieval augmented generation, and also or fine tuning, right? Because you can do RAG or you can just fine tune the model. There are different ways to do these things, but I think we're going to get closer and closer to accuracy and mitigate that problem, which means this, in my opinion, is the new application fabric. Really, foundational models are going to be the new application fabric for building new stuff for business. What do you think?
Oh, I agree. I mean, I think again, like picking from a static palette, like we're sort of used to doing for our UI elements or the other design elements, or even if it's a purely integrated product, I think that what you will just see is more and more opportunity to
What's
remove
going on?
more and more opportunity to remove static. More and more opportunity
Yeah, I
to
can.
remove static references to things and replace them with inferred references. And I think it's like important to
That's
not just
crazy.
It's like an easy sentence to say, and then like you think about what this does to our application, and then
Right.
I mean, not to add another dimension of complexity, but remember that these things have a memory too. They have a state and they have a persistence. So remember also now that this dynamic text box that's helping you perform some task, it might operate differently on a Friday, having learned what you've done with that part of the application throughout the week, or if it's collaborating with other teams who also have their own local models that they're generating it against. We'll be able to provide a team-wide or organizational context to those prompts, right? So it's like it's one thing to make that sentence like, yeah, we're going to swap out text and we're going to replace it with something generated from an LLM. But if you really think now about the capabilities of these LLMs, the widespread data that they have, I mean, what do we do as developers when we're designing the app? Like we try our best to infer, okay, well, these are the 5 prompts that if I set somebody inside the app, it'll probably hit 80% of the use cases, and I'll do my best, right? But now we're actually able to have a foundational model that can make that inference in microseconds at scale anytime you need it.
That's just crazy. I mean, really. So I think that what's going to happen here is bit by bit, different components of the enterprise software landscape are going to be absorbed, almost like the Borg, basically. You're going to see it in customer service, in chatbots for sure, because chatbots, which I think came along because search really stunk. I mean, Google search, of course, is legendary, but if you go to individual websites, over the years, I've tested this theory many, many times. I go to some individual corporate website, go to the search, type in something I want to find, and just get absolute crap. Just nothing at all, like press releases that are meaningless and just other things that are not even close to what I was looking for. And it's because they don't have the power. They don't have the capacity to do what Google has been very good at. But now, whether it's Bard or ChatGPT, these other things, I mean, you don't just get a list of links to go to. You can tell this LLM to tell you a whole story about something and give you examples of companies in a particular space, and boom, there it is in seconds. No media organization can compete with that. No educational framework can compete with that. We're going to have to find ways to ride this wave and to kind of work on the surfboards. Am I right?
I think so. I mean, there was a very interesting article the other day that came out that talked about how educators and psychologists are actually some of the best prompt engineers,
Interesting.
in that they have, because you're able to deal with, again, on a very unsophisticated neuronal level, but basically the same type of interaction that you might have trying to coax an answer, out of a student, right? Being able to understand the response and then reframe it in a way that's more targeted, more specific, cuts through a lot of the signal to noise that these models have to deal with. So it's actually super interesting. We're finding that like teaching techniques that have been useful in the past can now be transpiled into prompt engineering in some ways, right? So when we talk about like these things coming and not being able to compete, like I agree, but I still maintain that all I do believe that this is something very new. I still think what we're talking about is distributing existing technology to more people, like we've talked about with William Gibson and Futures Already Here, Not Evenly Distributed. I think that the proliferation of these models is really just more of this lab technology, kind of reaching more of the masses. But then I also think that it doesn't have to be mutually exclusive, this relationship, that it's going to replace work that we're doing. Instead, I kind of see this as like, when's the last time anything was designed, with a slide rule, right? But it doesn't mean that we're still not trying to solve the same equations we've always been trying to solve. We can just do it faster, and more people can do it in an experience that's more personal.
Think about the amount of time people have spent just nitpicking their PowerPoint presentations, doing all this stuff. We're talking hours and hours of work that is really pretty boring. I got to tell you, I've never been a fan of PowerPoint from the earliest days. I never liked it. I never liked the architecture of the software, and just it's kind of kludgy. Now, who cares? You just pump it in and like have this engine build your presentation for you. I mean, goodness gracious, especially for things where you want a slight variation, like in tone. Like I mentioned, this is for the sales team, this is for marketing, this is for the board of directors, this over here is for the IT folks with the same information, but it'll use a different tone of voice and different terminology. I mean, that is a huge time saver. So I think this is where a lot of the value is going to come from these foundational models and from this new approach is it's tackling a lot of really boring, tedious stuff incredibly well. So we can get onto the more interesting things of figuring out what are we going to do for our business? How are we going to adapt? How are we going to get more customers? How are we going to live in this new world? That's the stuff that humans need to figure out, which, these LLMs can help with ideas, but people have to make decisions and figure stuff out. I think that's where the value is going to come. What do you think?
I mean, I think you nailed it in that we're still talking about the reduction of toil through automation, right? It's just that now we have elevated what that toil can be, right? Whereas we've maybe been able to choreograph things in the past, like pulling data from some system and putting it in some report and pushing that report via Slack or email. That might have been a manual step before, right? Now we have much more complicated tasks, things that you might even employ like a executive assistant or intern or someone like that to do. But where we shouldn't get scared, going back to what I said before about Uber, is that how many people have the means and wherewithal, whether in their own personal role at their job right now or at home, to have a full-time, and I should also say 24/7 and cognitive fatigue immune second brain kind of capability that we're starting to see, coming out of being able to have these models more generally available to people, right? And again, like I do have an agenda of wanting people to feel, more comfortable with this technology, but also going back to a more objective thing. You and I have talked so many times about the importance of self-service as a means of reducing friction and a means of better resilience and autonomy. And what that does for throughput, right, in our traditional, throughput sort of driven model.
Right.
And so, I think that moreover, when we talk about this as something that can give us each an individual capability that we didn't have before, it's up to us how we choose to adopt it and use it.
Yeah, and as you were talking there, I was thinking to myself, what's going on here, which is very interesting. This retrieval augmented generation. Think about issues like governance and policies, privacy policies around PII or who has access to which data, all these different kinds of rules that we've put in place that amount to IT governance or data governance, for example. I think what's going to happen is a lot of that stuff is going to show up in the G or in the RAG model as it comes back, right? That you're going to go in and say, oh, I want to know what sales were in this region, and it's going to go, oh, on the way back, it's going to say, I don't think you're authorized to see this information. Please check with your administrator or something. I think that's where we're going to see it, right? And I don't fully understand how this stuff works, to be honest, and I don't think too many people do. But that RAG model is probably going to come into play in lots of different ways, one of which is, of course, to improve accuracy and to ground it. Anchors of truth is what one guy called the embeddings, which I think is a great term. But then two, policy. I think you're going to embed your policies in here to protect who can see which information and who can do what. But what do you think?
Well, I mean, first of all, the model, I think, it's another level of being able to add a dynamic response and a more comprehensive response. It's often been termed just like giving your model access to the internet, right? Or just giving your model the internet, which is kind of the net same effect, right? I mean, like imagine that what you really have with a trained model is a highly complex lithography, right? Almost like every single vector becomes its own sort of inference line, and now you're dealing with billions and billions of these. But they're fixed, right? That's when you're dealing with ChatGPT and it's telling you, I don't know anything after September 2021 or whatever it is. The what's happening is because you're dealing with a fixed set of vectors that have been stuck inside of that model. So now you're saying, all right, well, if I need to reason for some piece of data that I don't have, I'm giving you the ability to reach out to some other system and augment your inference with some piece of data, right? Now, why does this work so well in the enterprise? Because there are so many places that these models are going to be able to reach out to adapt the data that they're trying to give back to solve the problem, right?
Right.
It makes the model, it becomes a very easy architecture to make the model more domain driven, right? So that that model can sit inside of your organization and improve its accuracy. I mean, that's what all of this is about, right? Hallucinations are a big problem. Accuracy is a big problem. Trust is a big problem. That's why explainability was like the first hurdle to try to hit with a lot of these models. Can I give the user some confidence that, you know, this model, for lack of a better word, knows why it's doing what it's doing, or at least knows the source of what made it infer the way that it inferred, right? Now, this isn't any different, though, that when a researcher is expected to cite sources or cite a bibliography.
Right.
Does that mean just because the bibliography is there that the research is perfect? Absolutely not. Absolutely not. It's subject to misinterpretation. It's subject to typographical error, any of these things, right? Which is why we need peer review. And again, we're not ready, I think, at this point, in a general and foundational way, to let these models run wild. But I do think that we have the constraints now. I do think we already have the technology now to trust these models to generate small bits of dynamic contextual text that could do things like replace some of the UI elements that I've talked about before.
Yeah.
I think that's the level where we're at right now.
Well, and you know, I'll give you a little thought that I had on a webinar a couple months ago. I was doing a webinar with Vertica, and we were talking about these new models and how it's going to change things. And I thought to myself before the show, you know, in the database world, you have inner joins and outer joins, and these things are pretty complex, and they're fairly costly in terms of the compute power and, you know, how much time it takes and all that fun stuff. And the LLMs just don't really care about that, right?
Yeah.
And what I think is interesting is like, and I kind of wonder to myself, yes, again, we have to be careful, right? But one of my buddies told me, like, look, you can train your own model on your enterprise data warehouse and then just feed it the updates, and you'll get really good information from there. So it's like, huh, so are you saying I don't need the warehouse now? I mean, I think that you will want certainly to have all these sources of truth, these systems of record, basically your ERP, your warehouse, different things of this nature. But over time, these foundational models, I think, are going to start picking up little bits and pieces of what that stuff can do. And what really struck my fancy was how it comes about picking the bits and pieces that it chooses. What is that function? Because it's different, much different than in a prescriptive database or like a SQL query, where you're saying, I want this set of data from this table and that set of data from that table. Here you're just asking a question that goes, oh, let me go grab 5 things from wherever and put them together. Like, is the traditional model of persisting, storing data in relational databases, is that going to be kind of out the window? What do you think?
I don't think it's ever going to be out the window, right? I mean, I think like there's going to be a place where you don't need the LLM to replace that widget, or you really will see a benefit from having a data model that's still more relational. I think what you might see, though, is kind of, if you remember, when we went from like these patterns of taking like unstructured data, cleaning that data. This is early data engineering, right? Taking unstructured data, turning around and cleaning that data in some canonical way, and then restoring that data, right? Sometimes that's called compression, right? Sometimes that's
Right.
called, you know, or right. I mean, like it depends on what we want to look at. I mean, there has been speculation, right? I mean, again, this is very theoretical, and we're in the art of the possible here. But imagine, for instance, you know, we know about, you know, compressed archives now, and compressed archives could almost be thought of as like a real-time package, right? Where, okay, we took the state of this application, now we compressed it into a single file that we could ship. If we had a factory that was capable of generating these artifacts, that could do it by an inference model, and the way that the same information has now, instead of being put in this raw format, has now been annealed into a trained model that can generate the same artifacts, then what's the difference? What's the difference between compressing an original piece of data or being able to generate the exact same data, but being able to generate an unlimited corpus of it from a finite source, right? That's better than compression. right? That takes us from being able to package something statically to being able to generate something dynamically. But it's not magic, right? The information, the bits and pieces that were there that would have been compressed originally are still there. They're just there in the form of an inference model, as opposed to raw data.
Well, and that kind of brings us to the whole topic of vector databases, and everyone's got a vector database now. And just to explain to our audience, and I'll see if I can get this right, with embeddings for a large language model, let's say you're putting them into a vector database, what you're basically doing is converting text to numeric values. And I think the main reason for that is because it's easier to do statistical analysis on numeric values than it is on text. And also, you can then find these relationships, because that's what the vectors are. Basically, they are numeric values for text strings, either letters, words, sentences, paragraphs, all that kind of stuff. And then what these systems have are weightings, basically. So when you enter your prompt, the vector, the LLM hits the vector database, like, all right, what do I have here? And it looks for similarities, like, okay, this looks similar to what that was, and that's how it predicts the text that it thinks you want to read, basically. But you think about that, and it's very interesting. So you can also vectorize images, like think brain scans, for example, MRIs. Well, if you vectorize MRIs, now I can more easily analyze this MRI versus that MRI, look for patterns in behavior for MS or Alzheimer's or whatever. And those files are a lot smaller and they're a lot more useful. So it's like, well, put your MRI files in cold storage, in ice cold storage somewhere, just vectorize them all, and now you basically have a much cleaner, easier material to play with. I mean, is that about right?
That's pretty close. I mean, so a vector is going to be the most basic way that we are currently storing data to train a model, because it lends itself to the physical structure of a neuron that we're trying to replicate in sort of a digital form, right?
All right.
So a vector you could think of in relative math is effectively an ordinal that contains two pieces of data, right? It contains a point in space, and then it contains a direction, right? And that direction can also have a length, right? So you can think of, like, for instance, a ray, R-A-Y, ray, right, is a form of a vector. You have an origin point, and then you have information encoded, and it tells you how extreme that ray is and in what direction it's pointing. So if you can think back for a second and think that these neuronal models are effectively trying to recreate the substrate of a cortex of a brain, right? But doing with a mathematical model, individual neurons are in fact vectors that say, okay, I have a piece of data, and then I also have an attachment to some other piece of data in the next layer of the model. Right? Now we have a database that makes it a lot easier to query against multiple deep layers in a network to try to see if the model can infer patterns within that data. So effectively, yes, what you're saying is possible. That then we could look at having a data structure that allows us, instead of examining the raw tokens or elements of the data that we're trying to look at, we instead are able to analyze the relationships between those words. The best way that I can think of to conceptualize right now, thinking how we've evolved LLMs and foundational models to understand next token, which is effectively what an LLM is doing. It's just generating the most likely next token in a sentence, just doing it very, very well, is to think about the way that we taught computers to play chess, right? When we did this back in the 60s or whatever it was, effectively what we did was just load up a database full of all of these existing chess games that had been played in the past. And the computer just said, okay, I'm going to recognize a board configuration. I'm going to query my database for a time that the board looked exactly like the board looks right now to the computer.
Oh, interesting. Huh,
and I'm just going to see who won the game, and what move did they take.
That's fun.
That's it. So I'm going to calculate the next move, right, based on the highest statistical likelihood of winning the game, based on the history of games that have been played in the past.